Hi guys, welcome to Learn Electronics Repair. And I have something, well, different for the channel here because I've never tried to repair one of these before. So this is the receiver from a SHURE radio microphone. This belongs to Detlef. He actually picked this up at the flea market a little while ago for €5. It came without any power supply or anything else. We can see 14 to 18 volts, 500 milliamps, and it says center positive. Okay. This has a line input and microphone input, so you can actually put a wired microphone into here as well, from what I can see. Micro line, plus it's a radio mic receiver. It also shows two antenna A and B inputs, which are BNC. Maybe it needs a little plug-on antenna to even work, I don't know. We'd have to find the manual. But the problem with this is that basically it lights up the display, or rather the backlight of the display lights up, but nothing appears on there, no menus or anything. So no doubt this is one of these microcontroller or microprocessor controlled audio items. I would say I don't have the best track record of repairing these. Detlef says it's not that important. He only paid €5 for it anyway. But let's have a look inside. Let's see if we can actually get anywhere with this. At least maybe figure out what is wrong with it if we can't repair it. But hey, who knows? Let's give it a go. Well, having taken out more screws than I probably needed to, this has quite an unusual way to come out. So we have a ribbon cable here which is not inserted very well. That might actually be the problem, or that might just be when I was trying to disassemble it. So you take that off there, and then the whole thing slides out backwards from what I can see. How about that? How about that? This won't go all the way through, but now I can actually unplug this here and take this back out forwards. Okay, so yeah, that's how it comes apart. All those other screws I removed are not part of the assembly. This is like cast all in one, yeah? Okay, so I have it disassembled. As I expected, lots of ICs. I don't actually see a microcontroller, but I'm pretty sure there's one somewhere. There's nothing underneath at least. Oh yeah, that's probably the processor just there. I'll connect this to my bench power supply. So as I said, positive to the center, 14 to 18 volts. So 15 or 16 sounds good to me. And let's see what it does. I mean, Detlef says this will light up and nothing else will happen. And I'm confident enough to say that's correct. But I guess you guys want to see. So we'll do it. I've connected the cable back on. So that's inserted straight, both ends. Although it may well have been okay before, to be honest. I have the power supply here. I've set it to 16 volts. How much current does it draw? About 200 milliamps. Okay. And yes, like Det says, the display lights up, but nothing else happens. Okay, so that's the problem with this. Where to start then? Well, I don't see any buck converters in here, so it's not like I can just find coils and see what voltage is on them. I do see some MOSFETs by the looks of it. This area looks like power supply to me with linear regulators, so we can look at the voltages on these. That might give us some indication. We can also look up the data sheets for the ICs and find out where the power rails are and what power rails we should expect. We can check that. I see two crystals here. It seems fairly evident that the display either isn't working and there's a couple of chips on here, could be EEPROMs or something like that. Could also be some sort of voltage regulators. I see two more capacitors here. Another chip, again that could be a processor or something that's driving this display. Okay. We could try and find a schematic. I have a number of the board, we have the model number. Why not? Let's have a look for a schematic as well. And we could maybe find some high-res photos. Looks like something should plug on here. There isn't, but I don't think there's a board or anything missing, to be quite honest. But maybe we can find some photos of it just to confirm that. So I think first of those, let's just see if we can find any schematics or service manual. Well, I didn't find any schematics or service manual. What I did find is a video, which we see here. So this guy has a faulty one of these. This is dead, so the display doesn't even light up. And he has some shorted capacitors here. I had a look at his video. So these two are voltage regulators, and there's another voltage regulator type chip under his finger at the moment. I'll show you that. And there are some voltages marked on here. I haven't watched the whole video, but enough to get an idea. And he has some short circuits on the rails. So this is probably the next place to go. Let's see what voltages we have here. And he mentioned some test points marked here, plus 12 volts. This is a 12 volt supply. This one is a 10 volt supply. He says this is also a regulator. The output's on pin 3, which goes to here by the looks of it. Yeah, probably to there, I'm guessing, positive. So we have some supply rails. Let's look at those and see what we find on our unit. So 12 volts we have. 10 volts we have, 9.95. And this other supply which is coming from here, what is this? 5 volts, that's a 5 volt supply. So we have those voltages present. Okay. So we don't have a short around here which the other guy had. Let's have a look to see what this chip is. So I'm going to have to remove the sticker to see. I'm interested to see what supply rail this, as this could run on 5 volts. It could be something else. And we can check on the two crystals as well to see if they are oscillating. And I'm also wondering, is there an EEPROM on here? A BIOS type chip, which we can have a look to see if that's being accessed using the oscilloscope. So those will be the next things I want to test. I've had a look around these various chips. I've looked up the data sheets. Some of them are op amps or quad op amps even. Some I don't recognize, and I can't find a data sheet either. In particular this one and this one, I can't find any data sheet for those. Okay, could be an EEPROM, but they seem to be in the wrong position in the circuit to me, so I don't really think so, in all honesty. Again, this is another one I couldn't identify. This one is a quad op amp. This one is like a radio receiver all-in-one type chip. It has a 10 volt supply. That's within what the datasheet says, so that seems to be at least has power. LM837 is another op amp, or rather quad op amp. The quad op amps appear to have a plus 10 volt supply and ground, so single supply rail. I haven't looked at this chip just yet, but there's a crystal here, so we can see if that one is oscillating. There's another crystal as well, so let's check this one while we're here. And that one is oscillating. Let's have a look. So yeah, there we have it. That says 32.7 kilohertz. That to me is a real-time clock crystal. Yep. And Detlef is just confirmed for you guys. And the other one is over here. What about this one? Well, that's just gone up. Just turn the sensitivity down a little bit. Didn't see any oscillation. What do we have? That one isn't running. It just has a small voltage offset on it. Yeah, that isn't running. Look at the other pin on it. Yeah, we have a crystal here that is not oscillating. So that's possibly a good reason why this thing isn't working. Let's look at what frequency that is and let's figure out where it goes to. Looks like it might go down there, but I think that is Yeah, that's one of the op amp or quad op amp chips. Okay, I'll figure out where this goes to and let's see what the markings say on it. So the oscillator that isn't running is this one that says SOX 3. Anything else on the side of it? No, not marked. So SOX3. Let's find a data sheet to see what that is. And would you believe it, guys? I can't find a data sheet. SOX3 data sheet. Nothing. SOX3. Oh, something to do with genetics. Yeah, the SOX3. It's a gene. Well, that's strange because it looks like a crystal to me. It definitely is a crystal. This one is marked Y3, the one that is running over there. Okay. This one on the silk screen says Y2. No, sorry, Y1. So there's another one somewhere. In actual fact, there are 3 of them on here. Okay, well, I'll show you where it goes to, and I'll show you the data sheet. And one of you more op amp specialists than me, tell me that if we can see if this should be oscillating. So one end of the crystal goes to pin 7 of this chip, and that also goes to some resistors around here we can see. Okay, and this chip is the MC33179D, so that is a quad op amp. The other end of the crystal goes to this capacitor. It may go elsewhere, but it definitely goes to this capacitor, and from the other end of the capacitor goes to pin 10 on the same IC, which also goes across here to a resistor and back up that way. You can see it. Okay, so basically the crystal is wired between the output of this op amp and the input on that op amp, okay, with some other components around, and there's a capacitor in series with the crystal, no doubt a small value one. Okay, so I think that is part of an oscillator type circuit and it should be oscillating. This would depend on some extent to what voltage we have on these other pins. So I'm going to measure them. Let's see what some of you guys think. Okay. The crystal, I have no idea what it is, and Det can't find a data sheet for that either. I know this chip has power. I could have a look because there's at least another one of these chips on the PCB to see whether this one is hotter or colder than the rest, but that won't particularly tell us anything definitive. So let's look at the voltages. So we want to have a look on 5, 6, 7, 8, 9, 10. Okay. So 5, well, we can go here. 5 volts. 5 volts. 5 volts, all the same. Okay, and then it comes back in on this one. 4.95. 5, so there's a difference. 5.47. Okay. So this one is higher than this one. So the inverting input is higher than the non-inverting input. So you'd expect this to actually go low, and it isn't. So guys, I have the non-inverting input lower than the inverting input. So you'd expect the output of this to go low and probably right down to the supply rail with the difference we have, and it isn't. I mean, we know we have a plus 10 and a 0 volt supply, but it's certainly not going anywhere down to 0, which I kind of expect it to do that given the difference between the inputs. I mean, admittedly, there are other resistors and components around here. This op amp up to plus or minus 18, it says dual supply, but I don't find another supply. I mean, it doesn't have to be dual supply. Remember, it can use a virtual ground basically as to give the output. So far, it seems to me this op amp isn't working properly. It's a low power but high output current. Yeah, high output current, low power, low noise, bipolar operational amplifier. And I don't think we can just stick something in there. I think if we're going to replace it, we need to replace it with the right thing. The one thing I just want to be sure is that this is not supposed to have a negative supply rail. So I have a look around the board to see if I can see one. The crystal, well, we can't do anything about it because we don't have a data sheet. Maybe one of you guys knows what that crystal should be. But crystals don't tend to fail as long as they've got kind of like the right voltage offset across them, they will oscillate. So my best guess so far is either there is a negative supply rail and I can't find it, which I'll have another quick look, or this op amp isn't working, or something in this circuit isn't working. Let's have a quick look to see if we can identify a negative supply rail. The first thing I will try to do is look at the area of the power supply with the thermal camera. Let's just see if anything's getting particularly warm. Okay, so we have a chip here which is quite warm. That's that regulator which is giving the 5-volt supply. I mean, that's the greatest voltage drops you would expect. That to probably get a bit warm actually, but it's 44 degrees. This is one of the voltage regulators, 37, 38, 34, 41 there, 42 on the capacitor, 49 maybe. So that's not getting particularly hot. I was just discussing this with Detlef, as I often do, and we're both of the opinion, or rather Det agrees with me, that if there was a negative supply rail on here generated from the positive input, there would be a buck type circuit somewhere with an inductor, yeah, or a little oscillator with a transformer. And we don't see, apart from this, which is an IF frequency transformer for the RF signal, we don't see one. So I strongly suspect that it is not a negative rail, that this in fact does run on a single supply rail plus 10 and the other end is ground. Also from where the negative supply rail would be to ground it reads short. I mean, I would agree with you, if we have a short circuit negative rail that would also show as short, but I just don't see any evidence that there is a negative supply rail in this. Okay, the problem with this repair, or should I say a problem with this repair, because there may be more than one problem, is that I don't know whether this should be oscillating or not. Okay, I have no prior experience of these. I've never looked at one before, so I don't know. I would assume it should be oscillating, but it's possible that because this is an op amp circuit, this is being controlled by something, and the something could be that. It's also quite possible this doesn't need an external clock. A lot of microcontrollers don't. It could also be that this is all working, but there's a problem with this circuitry, so you know, the display interface. There's another possibility. I'm a little bit surprised if that is the case, because there's some LEDs here and these are not doing anything either. Okay, so that makes me think, well, if there's a problem, it's a problem with the whole thing, including these LEDs. I think you might agree with me on that one. So I'm thinking probably not a problem with the actual display circuitry. Let's have a look to see what type of microcontroller we have here, see if that can help us. Well, we have this chip, just get a bit of a light across it. I think it says MC58HC. There are some other numbers. Let's see if we can find any information on this. Well, according to artificial stupidity, it says that the MC58HC is a 58-inch school milk cooler. Okay. All data sheet says MH. Well, in fact, it just says MC58000. Okay. Let's have a look. That's not the thing. Magdalene motion detector. I mean, motion processor. What is that thing? I don't think it's of any interest to us, but hey. No, so this is not it either. So high-speed pulse and direction signals for step motor system. So no, this is nothing to do with it either. This other number 908GP320, that finds nothing either. OKG8SH, go on, let's just try the first part of this. Well, people have searched for it. People have searched for that, but they've not found anything. So I'm not the first person to want to know what this thing is. So that route is closed to us. We can't go down this route. I wanted to see, hey, does it have its own crystal built in? It might do. It's got a capacitor across 2 pins here, but I have no idea. That looks like it's actually part of this circuit for the real-time clock. So all I can say is some sort of processor. What do we have on here? JS16AG. LM3914, that sounds more like a number. LM3914V. LM3914 dot bar display driver. Drives LEDs, LCDs or vacuum fluorescent display. Or dot display. Okay. Well, there were some LEDs on the front panel and there's a display on the front panel. No, this is, Luke, this is for the LEDs. Okay. 6.8 to 18 volt supply. Mode, so this is dot or bar. This is a, yeah, like a VU meter type thing, okay. And they show 2 of them, which is what we seem to have. So this brings me back down to what I was saying, really, that because the LED bar graphs are not working and the display isn't working, and I suspect we have one fault, it isn't going to be these chips, or I would say this one. What is this thing? PCF8576CH Philips LCD driver. What you would think it was going to be. This might tell us something. Well, we can see we have power, VDD, VLCD, another power, I think, clock, sync, oscillator. We see some things. Oh, SCLSDA. So this must be how it's controlled. In other words, how it gets the data. Yeah, so I2C bus, serial data in out, serial clock input, external clock on 4, supply voltage on 5, oscillator input on 6. So if we have a look around these, we should be able to see whether this is receiving any data to process, basically. Yeah. VSS ground. Okay, so VDD, voltage to the drains. This is a positive supply. This shows a pin out, but this is not my chip, unless it's just shown. No, this is CT. This is mine, CH. Okay, so we want to have a look around. Well, we can see pins 1, 2, 3, 4, 5. Let's go back to that list again. SDA says, okay, different pins. Yeah, okay, so 10, 11, 12, 13, 14 and 15. This is where we should be looking. Let's have a look to see what we have. So 14 is power, 15 is oscillator input, and 13 is a clock input. Okay, so this is 16, so 15, 14, 13, 12, 11, 10. Okay, so 10 looks like we can probe on this resistor here, and 11 on here. Okay, and that is SDA and SCL. So this is where the data comes in, and clock. I'll use my analog scope because it's just the easiest to see if something is going on. I'm not really concerned about what is going on, just more of it is something going on. So let's see, this is data. Let's switch it on. Yeah, something's going on. You can see it there. If something's happening, just switch off again, back on again. Yeah, there. So the processor is talking to it. That tells me basically the processor is running. This should be the clock. Again, what do we have? Yeah. So I'd say the processor is running. That's fairly certain. Some of these pins don't seem to be connected. Certainly 12 and 13. I mean, they could go under the chip. Could go under there, yeah. 14 is connected. Which is 14? That's supply. Okay, I've just set it to 5 volts per division. Let's have a quick look what's on that one. Yeah, 5 volts. Okay, just go to 2 volts per division. Yeah, 2.5 divisions. Okay, so it's got voltage supply. It's got data coming in. Is there anything on 15? Can I even easily get to this one without shorting something out? Let's have a go. That appears to have nothing on it, but it looks like it's not connected to anywhere, to be honest. Okay. There's some test points all around here, actually. We have S0 to 39 display segment outputs. Okay. Let's have a look. So those are going to be, yeah, all the way up this side and along here, basically, which is where a lot of these test points are. So let's just have a look to see if we see anything. Some of them are low. Some have about 5 volts on. Let's just have a look at one of these while we power it off and back on again, and do we see any activity at that point? We'll just pick one. No, doesn't seem to do anything. Well, these are just low. Let's just go to one again. Doesn't seem to do anything. Okay. It looks like, from what I can see, the microcontroller is sending information to this, and this isn't doing anything. It's got supply voltage. I'm not sure about this clock because it goes under there, if anything. But it seems possibly we have a faulty display controller or a faulty display, but I don't see anything on these test points really. There is something else we need to check though. So with the communication I2C bus, often that contains an address and data, so like an 8-bit address, 8-bit data, something like that, okay? But this chip appears to have sub-address inputs and a address input. We just find it A0 to A2, okay, on pins 16 to 18. So basically, yes, there, SA, that's the other one as well, 19, SA0. So basically the processor can address this chip, and it sort of says like, this data is for you on the I2C bus, and we need to have a look to see if it's being addressed. So although we can see data on the bus, it's not necessarily meant for this chip. Yeah, so let's have a look. So this is on pins 16, 17, 18, 19. What do we have? Well, we have some test points. Yeah, 16. 14, this was power, 5 volts, 01A, sorry, this is a 10k resistor. This will be a pull-up resistor. There's a point there, look, there's some more pull-ups here as well, and these are all test points. In fact, there's another one here for something or other. So let's just have a look to see what's happening here. So it's switched on at the moment, but I think I'm probably best probing the test point and then powering it on. Okay, so we're on that one. Let me just switch this off. and then switch back on again. So that's just high. Never changes. Yeah, that's just a bad connection there, you can see. How about this one? So again, that's low. Switch off. Oh, if there was anything on it, I could hardly see it. Let's just try. So I'm on 2 volts per division. I'm now on 1 volts per division. Okay, let's try again. I'll just go to there because it might go off the screen. So this one, power off. No, like a little bit of noise or something. Nothing there. This one. Again, nothing there. This one. Again, nothing there. And this one. Again, nothing there. So, although we see clock and data, this chip never gets addressed from what I can see. So that's why it's not doing anything. Why it's not driving the display. Okay, so that kind of makes sense because we also know that these bar graphs are not working either, and these are separate chips, and it seems very unlikely we're going to have a fault on both. It also seems very unlikely we're going to have a faulty ribbon cable which would affect both, although that is not difficult to test, so we can just test that. And that brings me back really to the microcontroller again. Now I've actually managed to find a datasheet for it now. But first, I'll just check this ribbon cable. Yeah, cable's okay. So this brings me back to a couple of possibilities, I think, now. The processor, which is here. And it's a very long data sheet, but I had a bit of a look through some of it at least. So the first thing I can see is that you can have a 32 kilohertz clock crystal attached to it, okay? It also has an internal clock as well. Tells us a lot about it. It also tells us that it runs on 5 volts. We know we have a 5 volt supply. It tells us it has SPI, but we know that because we can see the I2C communication coming out of it. Okay. And plenty of other things, but it doesn't really tell us much what we can do with it, because basically it just has output ports that talk to various parts of this unit. Okay, it also tells us it has flash memory built in for program storage. Yeah, in-circuit programming allows the operating program to be loaded into the flash memory, which you can load into there. It tells you how to do it actually. Yeah. So what I seem to have here, basically, I'm sure this display works, the fact that they're independent, neither working, and we can see now that this is not being addressed, but we can see there is activity on the I2C bus, which is almost certainly coming from here. I can't imagine it comes from anywhere else. So this is doing something, but it's not doing what it's supposed to do, or not getting that far. The problem could be over here with this chip and the oscillator that isn't running, and the only way I can really prove that would be to order another op amp, get some of these op amps and see if it makes any difference. And that's basically where I am with it. I could switch a couple of op amps around. Having said that, I may upset something else if I put this one in the other position. I believe there are only 2 on here anyway, so I think, in all honesty, yeah, I can get the op amps. They're very cheap, so why not? I don't see any point in replacing this chip because I'm sure it actually is working. The same, I'm sure that these are actually working, and I can't do anything with this. I mean, what can I do if it's not working properly, if the flash memory is corrupted? Yeah, at least without another one of these, and then you could switch them over and say, well, is it that? I mean, it's going to be fairly easy to solder and unsolder, but I don't have another one. Okay, so guys, that's where I am with it. I think it was an interesting experiment, if you like, or experience. We have some idea how to go about this sort of fault, but at the end of the day, the only thing I can say is there seems to be something wrong with that. And I said that a long time ago back in this video. Okay guys, down there, we've got the live stream on Sunday. If you want to go further, why not? Let's do it together. If you want to see something else tested on this, let's do it live. If you can't make the live stream, let us know in the comments on this video. Yeah, and I can do that on the live stream, and then you can watch it later. Okay, so there you go guys. Failed, but interesting. Hope you enjoyed that, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now guys.